Hello, I'm Derek Jacoby. Welcome to the Pacific Coastal Computing Association podcast. I'm your host today, but I have with me a whole bunch of co hosts. This is our team at PCCA who have been working on the Knowledge Graph product. This is a reliable chatbot that has a graph knowledge base based back end. And on our team, we've got a number of people both on that back end as well as front end applications of the Knowledge Graph product. And what we wanted to do today was just let you meet the team and hear a little bit more about what they've each been working on. And so maybe I'll start with one of our superstar backend developers, Kieran.
Hi, I'm Kieran. I'm studying computer science at the University of Victoria. This summer, I've been working on the backend development. So, how do we take a document and make a knowledge graph from it? I've been doing a bunch of the initial setup for document ingestion, query functionality, and the basic server endpoints.
Cool. Tell me a little bit more about what that means. When you ingest a document, what happens?
So, when we ingest a document, what we're doing is we're extracting subject object predicate triples from it. So something like cats adore catnip. And what we do there additionally is keep track of where we found that information in the document so that we can reference it later. And then we take all of that and
Cool.
build a knowledge graph from it.
Awesome. And what's a knowledge graph specifically? How's a knowledge graph different from just any other database of information?
A knowledge graph holds a lot more specific information. So, for example, instead of having a chunk of text talking about the habits of cats, you would have just triples like cats like catnip, and maybe catnip is a plant. And from there, you can create a graph and get a connection between cats and plants through catnip.
Well, great. Thanks so much, Kieran. I'm going to next pass things off to another one of our backend developers, Nathan, who's been working hard at doing a cloud native implementation of some of these algorithms.
Yeah, hey, I'm Nathan. I'm a fourth year computer science student at the University of Victoria as well. And yeah, this summer I took our knowledge graph backend from kind of a monolithic Python server over to a set of lean microservices that we're deploying on AWS. So I'd like to talk a little bit about that. The starting point was just kind of this classic monolith that was handling a bunch of different operations like file intake, processing, data writes, background jobs, and also hosting an API. So that was all one process, and that's kind of where I established a few goals for moving our architecture to AWS. Um, one of which is isolating responsibilities, just creating some clear contracts between components. I also wanted to add back pressure and retries where they belonged in this sort of complicated ingestion pipeline. And I also wanted to make deployments independent so that we could move faster and also deploy to different tenancies with just a few deployment scripts. So yeah, I split the system into smaller services. Each one's independent and has its own responsibilities. And then we're using Redis to facilitate sort of a message-based handoff system, and that was really nice. It helped me leverage sort of a concurrency control system and add observability at boundaries between services. I was also able to keep the data models and error shapes consistent in the system so that code reads the same across all of the different services. And a little more about that bounded concurrency. So if it's featuring a exponential backoff with jitter, and we're using circuit breakers around the external calls. So essentially, if a worker dies mid task, another one can just pick it up safely. Um, some of the code infrastructure that helped me facilitate this, I added a sort of a standardized service scaffold. Essentially, it's a template for the sort of architectural pieces of a service that include structured logging, health checks, uh, a graceful startup shutdown system and consistent error semantics. Every service, though, it initializes its own set of client abstractions that manage interaction with Postgres, a graph database, Redis, and S3. So, yeah, to make that sort of sustainable, I built that kind of service template in a shared utilities module so that the code between all of the services is standardized. Um, and also that shared utilities module sort of hosts like core types and helpers and all kinds of things that avoid duplication between the service container code. So yeah, I guess kind of a good segue into that is sort of our deployment structure. So I moved into container images, and they all have a simple, repeatable endpoint, entry point. Services are deployed independently though, and so each one can be scaled horizontally with AWS. And yeah, we're leveraging several Amazon services now, mainly like an API gateway, EC2, ECS, S3. And yeah, that's really let us sort of scale our product to different clients and make different forks for special needs and whatnot. So yeah, that's the refactor. It's the same product. It's got the same sort of outcomes, but now there's a clear ownership, better reliability, and just a platform that our team can develop on. I think a bit easier. So yeah.
That's great. Thanks, Nathan. Great description. What's been the most challenging piece in your summer so far?
Yeah, I think learning how to manage a graph database, and that's sort of come with learning OpenCipher. I mean, it's been the most challenging, but it's also been the most fun to figure out sort of the complex cipher queries that help us manage data input to that database and merging and all that kind of cool, crazy stuff.
Fantastic. Thanks so much. Let's turn over now to Piyush and tell me a little bit about yourself and what you've been working on.
Yeah, so my name is Piyush Acharya. I'm a rising senior in high school from Bellevue, Washington. And my work with Insurgent it follows a slew of projects that I worked with Derek in recent years. So there's two main components of my work with Insurgent so far, and that's the front end and the back end. And um, particularly in the front end, I focused on something called a start triage system. And for context, the start triage is a medical triage system which is used to classify patients' severity level by dispatch. And what we worked on that project is um, using an LLM and a voice system to conduct that triage system, so that in large-scale emergency situations, dispatch can use it very effectively to classify and view severity levels across an entire city and automate the entire process. Next is the backend pieces, and this is what I've been working on more recently. So what we've been working on previously, so what Insurgent has been using previously is a more bottom-up approach of creating a concept graph. And for context, a concept graph is essentially taking your knowledge graph and grouping it into distinct buckets of different concepts. And what we've done previously is we've first created the knowledge graph and then created the concept graph from that. But now we're trying a new approach because that initial old approach has a couple issues, namely that stability is not present. Also, it's meaning that it doesn't yield the same concept map when you add new documents, and that's a big issue. Also, when you query that system, you might not. It looks for an exact match rather than a fuzzy match, and so searching is an issue with the previous bottom-up approach. So now we're trying a new approach called the top-down approach, and this is where we first create the concept graph, and then we create the knowledge graph from that. And so we are using embeddings to do this, and it's a really interesting process. All of our code is available, at least most of it, And on a high level, we are computing a score between of the cosine angle between the embeddings between different concepts, um, uh, to between different um, uh, phrases and concepts to create the concept graph. Um, so that concludes the backend work, what I've been working on, and there's still a lot more to do. I'm really excited for that.
Yeah, great. Thanks, Piyush. So tell me a little bit more about the concept extraction. And I think you're using DSPY. Is that something you want to talk about there as well?
Yeah, well, DSPY is something we do want to use, but I'm not using it currently just for this prototype form. What I'm doing here is really interesting, and this is a derivative of my fascination with locally stored large language models. I just love local models because they're free, they're private. There's a lot of benefits to them, and so I've been using the new GPT OSS model along with embedding models like the Nomic 1.5 embedding model. And so, for context, GPT OSS is a chat model, while the Nomic model is an embedding model. Um, so what we tried initially is an approach that uses the chat model, but that uses a lot of resources during the ingestion process. How can we make that more efficient? Um, to address that, we tried using an embedding model. And so what that does is it creates embeddings from different concepts, and using those embeddings, it's able to create the relationships and figure out how far apart a concept is and what those relations are. And so that's one piece. Another piece is using direct matching along with the fuzzy embedding system. And this is to ground the model and prevent hallucinations. And we found that computing a score between the cosine similarity and the direct matching seems to be the best solution here.
Yeah, fantastic. Super interesting stuff on the back end. I would love to, from there, go to a bit of the user representation of this. So most products these days, cloud-based products, have a back end server that's doing some of the heavy lifting and the concepts behind that's exposed through endpoints to a front end. And Jamie's been the architect of our front end application. Can you talk a bit about that?
Sure. There we go. Yeah, my name's Jamie. Yeah, I'm working on the front end. I graduated from UVic with a degree in computer science and psychology. Uh, for this project, I've been working mainly in TypeScript, React, and in a Next.js environment. Um, Over the summer, I created a few different UI pieces, including a chatbot uh, interface where users can ask questions about the documents that are ingested, which includes chat logging, message caching, and a voice to text mode that leverages Assembly AI's API. Um, I also worked on a document reader um, using React PDF's open source library for viewing and reading the documents that are uploaded, and a source browser for viewing and listing and going through the different sources that are returned in the dialog window in the chat. Uh, I also worked on the login screen, user authentication flow using Amazon's SDK, Cognito SDK. And I also worked on a network visualization using Cytoscape to visualize the knowledge graph as a network of nodes and edges with some coloring and highlighting features in there as well. Yeah, fun stuff.
Thanks, Jamie. So, talk to me a little bit about what your most challenging problem has been in the summer. You've solved a bunch of them.
Yeah, I think the most challenging problem for me would be the one that I'm working on currently right now, which is uh, getting which is text highlighting annotations in the PDF reader, which has been a lot more complicated than I anticipated.
Yeah, you've dove deep down into PDF representations of text and a whole bunch of things in the open source libraries you've been using. Excellent. Excellent. Thanks so much. Well, let's go from there to some of the uses of that front end framework. And a moment ago, we heard Piyush start to give the introduction on the start triage, which is something that Annie has pushed deeply into understanding the user aspects of. Do you want to take that?
Yeah, absolutely. Thank you so much, Derek. My name is Annie McClure. I'm a third year student at UVic on my first co-op, and my focus is mainly on health informatics and computer science in a combined degree. Given that, my main focus, as Derek mentioned, has been on the BC 911 call start triage pieces that Piyush mentioned earlier. So currently, if you call 911 and the call center is overloaded from, for example, a mass casualty event creating a huge number of calls, you'll be put on hold with silence until an operator is able to take your call. Instead, when the call centers are overloaded, our hope is to have an AI be able to take your call and help triage you instead of you being on hold, going through the emergency start triage system that BC EHS operators would use in that case. My contribution to the project has been to focus on and work more directly with David, who is a member of a high member in BCEHS, to modify these questions as they aren't particularly meant to be over the phone done by an AI, and then adding more questions about the background, such as when did these symptoms come on? Tell me exactly what's going on. And also questions about specific symptoms. Are you having chest pain? Are they having difficulty breathing? After discussing with Derek and David, I created the flowchart for the dialogue system. Using that flowchart and Piyush's initial code base for the dialogue system, along with AI-assisted coding tools such as Claude Code, I've worked on a working text implementation of the dialogue system we want. The next big step I'll be working on is to use Amazon Transcribe and other tools to set up the working voice system based off of that text implementation to have the conversation over the phone. To go along with this as a separate piece, I created the symptom visualizations for easily reviewing the results of the patient from the dialogue through the mapping pieces that Marissa will no doubt give more detail on after this. Overall, it's been a pleasure working with such a wonderful team and learning so much. I'm really looking forward to seeing how the rest of this term goes. And yeah, thank you.
Awesome. Thanks so much, Annie. One of the things that I've found really interesting about your journey this summer has been the mapping between user language and expert language.
Mhm.
Can you talk to me a little bit about how you've kind of put yourself in the user mindset, whether that user is the analyzer of the data or the person on the other end of the phone line?
Yeah, so one of the key things about a medical environment is they use a lot of jargon and lingo that we wouldn't tend to really use because it's quick, it's fast, efficient. Everyone knows what they mean. So, for instance, instead of the patient's coughing, they might say tussis to say, the patient is coughing. They might say difficulties breathing might become dyspnea, which is much shorter, much quicker. So it has certainly been a bit of a shift in my brain to go, okay, I can't think of fast breathing or fast heart rate or slow heart rate as I have to think of them as tachycardia, bradycardia. Uh, And working with David has certainly been helpful to review that, make sure I'm getting it right. But we definitely want the person on the phone to be talking in plain language and be able to understand everything that's going on, but then the doctor and medical experts on the other end to have their medical language from that.
Yeah, thanks. I find that one of the most fascinating problems in user interfaces is just learning to speak the right way for the user that you're talking to, which has come out in this one in spades.
Yes, absolutely.
Wonderful. Well, on the website, Marissa has been working and taking some of those phone triage results and doing fun things and visualizations out of them. Do you want to talk a bit about that work, Marissa?
Yeah, so I made an interface that kind of takes everything that Annie's been working on and puts it in a visualization. So the large portion of that is a graph where you're able to see all of the points of all of the responses, as well, and responses, I mean emergency responses. And then it has multiple different panels that you're able to then go through and filter by an incident. So if additionally a bunch of calls are coming based on the same incident, you're able to see that they are all kind of linked together. You're able to also filter through based on the symptoms, and it's all using the language of the ambulance attendants and medical professionals, which I just learned what some of those words are that have been in my code. um, Additionally, one of the big things that we were taking is Annie had a visualization of a lovely little diagram circle that will hopefully give a quick indicator to the responses of who in a region has what symptoms. So it'll be based on percentage. And one of the things is being able to select a specific area. So having it where we can put a circle around a certain amount of our little responses and seeing who in that area has tussis happening and having a nice visualization that'll hopefully be quick indicators for our ambulance attendants. Um, Additionally, I guess I forgot the initial introduction. I am Marissa. I am a math and computer science student at UVic, and not only have I been interning as a software developer here, I've also been completing my honors project under Derek and also Yvonne Cody. And that is something that is somewhat similar that I've been working on this summer, which has been a training simulator for emergency support services. So people who are usually responding and they're volunteers that'll respond to short-term supports given to those who are displaced and impacted by disasters. So similar calls, but less likely medical emergencies.
That's great. I had the opportunity to attend one of your presentations to the emergency response teams and was overwhelmed by the amount of participation you're getting from them. Can you talk a little bit about what your interaction with actual response teams has been?
Yeah, so I've actually volunteered with emergency support services for a couple years now, which is where, when creating an honors project, I kind of knew that that was the direction I was going to take and began discussing with them before running around trying to find people at UVic that had an interest. And I was very lucky to land on this team, as clearly the work that we're doing is very intertwined. And that has been very lovely because I've gotten a lot of support and it's just kind of been this back and forth of talking about kind of the areas of need within that program and the gaps in the program, one of which being access to training, especially with level one responses, which are responses that tend to be something that's like a house fire. That's going to be your most typical level one response. It's less than 10 people. Yeah, I hope that answered
Yeah,
it.
fantastic. Yeah, no, it's been great to see the support that you've gotten from those teams. So that's the team. Thanks so much for taking the time to describe all your work. Are there things about the summer that any of you want to say before we close here?
It has been very fun.
Excellent. Thanks,
Yeah.
Kieran. I absolutely agree. Yeah, this has been a fun summer. I've enjoyed working with all of you.
Yeah, thank you, Derek. This has been a really cool opportunity to dive into this sort of subfield of computer science and just, yeah, kind of submerge ourselves in AI and all this like cool research on knowledge graphs and um, kind of the LLM stuff. So thanks.
Yeah, I think it's been wonderful working with this team and Derek. I think the work we're doing has a huge, huge, huge potential for impact, and it feels really good working on a project that has that quality.
Excellent. Well, thank you so much, everybody, and thanks to all of our listeners. I'll end this episode of the PCCA podcast and see you all again soon. Thanks so much.